You know, for over a century, when you think factory, you think pollution, right? They take resources, make stuff, and leave a mess behind. But what if we could just flip that script completely? What if factories didn't just pollute less, but could actually heal the world around them? That's the amazing concept we're going to dive into today.
Okay, let's really wrap our heads around this. I want you to forget the old image of smokestacks and toxic sludge. Instead, just ask yourself this question. What if the very act of making things could also clean our air, restore our soil, and build a more abundant future? It sounds kind of like science fiction, I know, but the blueprint is already here.
For so long, we've been stuck in this old model on the left: extract, make, and waste. It's a one-way street, and it leads to a dead end. But this new model on the right? It's a circle. It's a closed loop, and it's basically copying what nature already does perfectly. It doesn't start with taking, it starts with regenerating. Then it makes, and then it reuses. In a system like this, nothing is ever really waste.
So, welcome aboard our little virtual tour. We're going to explore the park's living foundation, see how it turns waste into wealth, discover the incredible materials it creates from carbon, take a peek inside its energy brain, and then, of course, we'll look at the all-important bottom line. Let's jump in.
So our first stop, well, it's not actually in a factory at all. We're starting outside. Because the whole foundation of this system isn't concrete. It's a living, breathing landscape that weaves together clean energy, regenerative farming, and carbon removal, all in one spot.
And it's all built on this idea called agrivoltaics. Honestly, it's such a brilliantly simple concept. You're just growing crops, or maybe grazing animals, right underneath elevated solar panels. So you don't have to choose anymore. Is this land for farming, or is it for energy? Nope, you get both at the same time on the same piece of land.
And the power you get from combining these two? It's just incredible. Get this. Studies show this dual-use approach can boost how efficiently you're using that land by up to 186%. You're practically doubling the value of every acre. And that's not all. In hot, dry places, the shade from the panels actually helps the plants, boosting their growth and cutting water use by as much as 65%.
So the real genius here is that every single piece of this system is doing more than one job. It's making clean power, it's growing food, and it's actively pulling carbon straight out of the atmosphere. It does this with cool techniques like enhanced mineralization, which is a fancy way of saying you're adding special crushed rocks to the soil that naturally suck up CO2. It can even use plants to clean up polluted industrial land, turning old damaged sites green again.
All right, let's head over to our next stop and see where this goes. We're heading into the core processing units now, and this is where some real alchemy happens. We're talking about taking stuff we normally think of as liabilities, plastic trash, old electronics, industrial gunk, and turning it into something incredibly valuable.
Now, the park uses a ton of different technologies, but I want to focus on two absolute game changers that are designed to tackle our biggest waste headaches: microwave pyrolysis for plastics, and flash joule heating for e-waste and other nasty stuff. First, let's talk about plastic. Ugh, we throw away mountains of this stuff. So here, you take all that mixed plastic waste, toss it in one end, hit it with these super targeted microwaves, kind of like a crazy powerful microwave oven, and what comes out the other side? High-quality fuels and chemicals, with oil yields as high as 98%. It's a super clean and efficient way to basically unmake plastic and get all that value back.
Okay, this next one is wild. We're going to talk about how to literally mine our old garbage. It's a process called flash joule heating. You blast waste with this massive jolt of electricity, heating it up thousands of degrees in a split second. And just look at these recovery rates. You can pull out over 90% of those super valuable rare earth elements from old phones and laptops, and over 80% of critical metals like gallium from coal ash. It's basically urban mining, and it uses way less energy than digging this stuff out of the ground.
All right, time for stop number 3. We've talked energy, we've talked waste. Now, what about carbon? Well, instead of treating CO2 like a problem we have to bury deep underground, this system sees it as a building block, a resource for making the materials of tomorrow. A key technology here is something called turquoise hydrogen. It's a really smart way to handle carbon. So, first, the park takes CO2 it's captured and mixes it with green hydrogen to make synthetic methane. Then it uses heat to split that methane into two really useful things: clean hydrogen for fuel and pure solid carbon. And here's the kicker: no CO2 gets released in the process. It's all locked up safe in that solid carbon.
And we're not talking about just a pile of soot here. This solid carbon is the key ingredient for some seriously futuristic materials. I mean, think about it. Carbon nanotubes to replace copper wires, super lightweight stuff for aerospace, even fabrics that can block electromagnetic waves, and the building blocks for graphene. We are literally turning thin air into next-generation technology.
Okay, for our fourth stop, we're heading into the control room, the brains of the whole operation. With all these different things going on, making and using energy, you gotta wonder, how's it all managed? Well, this is where the park's central nervous system, its energy brain, comes in.
So the whole place basically runs as one big virtual power plant, and an AI is the conductor. This AI-powered smart grid is constantly, in real time, figuring out the absolute best use for every single bit of energy. Should it power the factory? Should it sell electricity back to the grid and make some money? Or should it store that energy for later? The AI makes those calls instantly to get the best economic and environmental results.
And to make sure that AI can be as smart as possible, the park doesn't just rely on one kind of battery. It uses a whole portfolio of energy storage. You've got your regular batteries for those quick short-term bursts of power. Then for medium-term storage, it does something really cool. It stores energy by compressing CO2. And for that long-term, seasonal storage, like saving summer sunshine for the dead of winter, it holds that energy chemically as that synthetic methane we talked about. It's a layered system that makes it ready for anything.
All right, for our last stop, let's pull back and look at the big picture. We're talking about the bottom line. Does this actually make sense financially, and what's the real-world impact?
What's so smart about this is that the business model is just as creative as the technology. It's not relying on just one source of income. The park makes money selling electricity, selling those advanced carbon materials, earning carbon credits for pulling CO2 from the air, and yeah, selling the food it grows. This layering of income makes the whole operation incredibly resilient.
And hey, this isn't just some fantasy on a spreadsheet. When you look at existing eco-industrial parks that use these kinds of circular ideas, the numbers are huge. We're talking potential combined economic gains of over $660 million. This proves that designing with nature isn't just good for the planet, it is really good for business.
And the proof is already out there, in the real world. Just look at South Korea. Their eco-parks are already slashing CO2 emissions by over 2 million tons every single year. They're saving massive amounts of energy. But this is the number that really blew my mind. In 2023, these parks accounted for 60% of South Korea's entire manufacturing output. 60%! So yeah, this isn't some tiny niche idea. This works, and it works at a massive scale.
And that really brings us to the core philosophy behind this whole thing. For way too long, sustainability has just meant being slightly less bad. This approach completely changes the game. The goal isn't just to minimize our negative impact anymore. The goal is to maximize our positive impact by building industrial systems that actively heal and regenerate the world.
So what's the big takeaway from all this? I think it's that the future doesn't have to be about doing with less or making sacrifices. This vision shows that by designing smarter systems, by mimicking nature's incredible efficiency, we can actually build a future of real, genuine abundance, with tons of clean energy, amazing new materials, and a healthier planet for all of us.
It's a pretty powerful vision, right? It's where deep ecology meets high-tech innovation. It flips the story from one of depletion to one of regeneration. And it really just leaves us with one big question to chew on. Are we looking at the blueprint for the next industrial revolution?